own online news portal, the Voices, you can access it, and we have project on internet research. This is a one-year program, 32 credit course worth of courses are incorporated. There are 5 courses related to theory, 1 practicals, 1 project. Practical about digital journalism and project is about internet research. Open learning system adopted by the Indira Gandhi National Open University follows certain characteristics. It's a flexible and convenient, can be customized as per your needs, and the same quality adopted in a postgraduate diploma in digital media. Catch up with the online and digital revolution. Learn more about this platform. Register for this diploma. Connect with us. We will learn together.
And welcome to the session. In today's session, we'll be discussing about database transactions, what they are, and then we will be discussing about the basic properties of database transactions. So what is a database transaction? Well, in a computer, a transaction is defined as the unit of work as far as database is concerned. So a small unit, but a unit of work. You may be aware about several banking transactions which you do, and bank is basically a very good example of database management system implementation. So suppose you are withdrawing money, that is a particular transaction which you are performing, all right? And you may be depositing the money, or you are transferring money from A's account to B's account, right? So the basic issue over here is a transaction would involve the manipulation of one or more data values in the database. For example, transfer of money from A's account to B's account will involve the handling of 2 accounts, manipulation of 2 accounts, A's account as well as B's account. So that is very, very important, that in a single transaction, multiple data items may be manipulated. And that is where the transaction becomes very, very important. Okay. Now the next point is that it requires reading and writing of database values. We'll talk about it a bit later. And database systems that deal with large number of concurrent transactions are called transaction processing system. Now, the point about reading and writing. So what happens that ultimately database is stored on a secondary storage device. So what happens that the A's account information is to be brought from secondary storage device to memory, same as with the B, and it is to be manipulated there. And then in order to make those changes permanent, they need to be written back, right? So that is why reading from the disk, right, or your SSD, which are the permanent storage device, you read it from the disk and then perform the manipulation and write back the data back. So that is a typical nature of database transaction, in a sense that data is to be read as well as written back. Now, a very simple transaction program we have shown. This is a typical withdrawal transaction program, and this is in hypothetical language. It is not a very structured, typical database language, but different database may provide you different kind of a thing. So this is a sort of pseudocode. All right. So for withdrawal, ultimately what you will be providing information about the account, which is X, and the withdrawal amount. So these two variables are required as far as for the transaction withdrawal. Then each transaction is enclosed between begin and end transaction markers. And if X exists, so suppose the account does not exist, then you cannot do anything. So what you are basically seeing is, if X exists, then read the balance. And if the balance is greater than the withdrawal amount, then only you allow the transaction to occur. So subtract withdrawal amount from X balance and then write this particular thing. So this is read and write situation, right? So you are reading it here, reading the balance and then writing it back. And then dispensing is going on with the some other the unit, which may be your maybe the person, or it may be ATM, wherever you are doing the thing. And finally, there is a commit. Once everything is done completely, then the commit marker would be raised. Else, it will display that this particular transaction cannot be processed, right? And overall, if it does not exist, then display account X is. If X does not exist, then you will be displaying the message that it does not exist. So like that, this is a typical transaction. Now, as we said, transaction can handle, in a particular transaction, you can manipulate more than one data items. So a simple sample transaction for that may be, now in this particular case, you are dealing with two accounts, X and Y, and you are doing transfer, and begin transaction and end transaction are the same. Now X and Y both are existing or not, otherwise you will be displaying the related message. And what you are doing first, you are reading balance of X, checking whether the transfer amount, it is more than the transfer amount, otherwise this particular transaction cannot take place. And once you have done, thereafter you are subtracting it from the balance, okay, and then you are reading the Y balance and adding into that particular balance the transfer amount, and finally you are committing. Now there are many more things which we have, I mean, just for the sake of simplification, we have not included those checks, but in an actual banking situation, many other checks will be there, like the amount should be in a particular limit these days, and so on and so forth. Okay. And otherwise, if and else is basically if and related else, where insufficient balance, if X balance is not greater than transfer amount, then insufficient balance will be displayed. So these are the two transactions. These are just the pseudocode for these particular transactions. It will just give you an appreciation of the fact that the transaction is technically a program as far as computer science is concerned, and what you are doing into that particular program is basically you are reading some data items, you are updating certain data items, and then writing them back into the database, and thereafter you are raising the markers. One is called commit, another is called rollback. Now commit marker is basically, it makes sure that all the changes made by the transactions are made permanent. Okay, so in a sense, you are forcing database to write this particular information back to secondary storage. Okay, and rollback is basically, it terminates the transaction and rejects any changes made by the transaction. So sometimes it may happen. For example, the ATM got stuck, so it is not dispensing the amount, right? So in that particular case, the transaction will be rolled back. Right. So this is how the transaction, you deal with the transaction situation, like how to deal with the commit. Commit is in the sense that now the transaction is committed. So whatever changes you have made, that should be made permanent. And rollback, like anything which has been done by the transaction, right, that should be rolled back. That should be going back to the original value, right? So these are the two things which each transaction have. In addition to commit and that rollback, the transaction also have a feature called buffer management. Now, buffer is an important term. Like databases are stored in secondary storage as data blocks, where they can be processed in the, whereas they can be processed in the main memory. So data is in the secondary storage device, that is our hard disk. Okay, but processing can take place only in the main memory, right? So the portion of main memory allotted for database processing is called a buffer, right? So buffer is the place where all the updating of data is going to take place. So to update a value X, the transaction program will read the block containing value X to the memory buffer. So there will be chunk of data which will be transferred. Why? Because a block of data, the size of a block of data is normally in MBs, right? So a chunk of information will be transferred, quite substantial amount of information will be transferred. Then the processes the value of X in the main memory buffer is going to take place, and then writes the value of X to the data block once the transaction commits. Okay, so a block of data on secondary storage may contain many data items as its size may be in megabytes. Further, a transaction processing system may modify several data items simultaneously. Okay, so the multiple transactions, for example, in a banking situation, multiple transactions may be going on simultaneously. So a number of data accounts, number of account balances might be getting modified at the same time, right? So, and you are using the information into the buffer. So the buffer actually will be basically many blocks will be transferred into several buffers, and what you will find, many data values are changing over a period of time. Right. So therefore, an interesting question for DBMS, database management system, is when should you write a data block back to secondary storage, right? And this is the process which is called the buffer management process. Okay. So buffer management, you need to have the policies, like when to write back this particular value or the data buffer back to the secondary storage device. So that is a very important decision which is taken in the DPMS. And the basic thing over there is that the transaction has to be reliable. If transactions are not reliable, then the problems are going to be many, right? So basically we are looking at some basic certain properties of a transaction, right? And the basic 4 properties of any transactions which we are looking forward to are called ACID properties of transaction. And each ACID basically stands for some term basically. So there are 4 things which are called the properties of transaction. First one is atomicity, second is consistency, third is the isolation, and the fourth is durability. All right. So let's talk about these properties in more details. What do we mean by these properties of the transaction? Well, the atomicity, it defines a transaction to be a single unit of processing. All right. So transaction is a single. It is to be performed in complete or not at all. So every update activity, okay, every update activity of transaction program will be performed, or no update activity will be performed. Okay. So none of the activities will be performed at all. So this is what is the atomicity. Now, we should explain everything with the help of an example. So let's look into a particular example. Suppose there is a transaction which transfers rupees 5,000 from account X to account Y. So assume that at the beginning of the transaction, before in fact the transaction has begun, the balance at X or account X is 10,000 rupees. And balance at the Y is 20,000 rupees. And now this is a typical consistent state. As soon as the transaction starts, right? Okay, so this is the time when the transaction starts, okay, and this is the place where the transaction is going to end. So what we really are saying, either meanwhile balance of X will be updated, so 5,000, it will be made from 10,000 to 5,000, whereas the value of Y balance has not been updated. As we have seen in the transaction program, there are steps. So just the balance of X has been updated, but Y balance has not been updated. Okay, so that is a state which may happen. And towards the end, what we are seeing here is both the activities are performed. That is, balance of X has been made 5,000, it was already done, and balance of Y has been updated to 25,000. So this becomes the consistent state. Now the atomicity claims that this particular atomicity says that all the operations of the transaction, that is subtraction as well as addition, both the operations will be performed or nothing at all. It doesn't acknowledge any intermediate state at all, right? So atomicity simply says every operation of the transaction will be performed. Otherwise, it is not an atomic. Atomic basically means a single unit, right? So even if there are two operations, right? Even if there are two operations, the single unit activity is to be performed. That is what is atomicity. Now next is consistency. Now consistency is a very interesting idea, where what we say, this property ensures that complete transaction execution takes a database from one consistent state to another consistent state. If a transaction fails, even then the database should come back to consistent state, either to the database state before the start of the transaction or the database state after the end of transaction. Now that's a very surprising thing to note or say. What exactly we are saying? So this is what we said, that the database is in consistent state before the start of the transaction. Database is in consistent state after the transaction has ended, right? Because the transaction has successfully ended. But in between, while the execution of transaction is taking place, the database may be an inconsistent state during execution of the transaction. So at this point of time, you can see that database is in inconsistent state because X balance has been deducted, Y balance has not yet been added. Now suppose at this point of time, there is a failure, right? So it depends on the database situation. If the database has committed, right, then the transaction will be brought to this particular state on restart. Remember that, because after failure, you don't know what is going on. But then DBMS is going to ensure that the database is in consistent state. All right. And suppose we have not committed, the transaction has not yet committed, then the database will be brought to this particular consistent state. So this is what the consistency requirement of a database system talks about. It is a very, very important requirement for a database management system, that the database, when a transaction starts, right, we believe that the database is in consistent state, and after the transaction ends, the database is in consistent state. Now consider the situation when multiple thousand transactions are going on in a banking situation. Even in those situations, the idea is the same. If the transaction has committed, then bring the transaction to the next consistent state. Or if transaction has not committed, bring the transaction to the previous committed state. Now this is something which, if you see the recovery kind of a thing, or recovery mechanisms in a database management system, this is exactly what is ensured. Now the next property as far as transactions are concerned is called isolation or independence. Now, this isolation property states that the updates of a transaction should not be visible till they are committed. All right? This is a very important point. Isolation guarantees that the progress of a transaction does not affect the outcome of another transaction. For example, if another transaction, let's say a withdrawal transaction that withdraws an amount of rupees 5,000 from an account X is in progress, then failure or success of ongoing transactions should not affect the outcome of other transactions. So this is a very important phenomenon. Consider our example once again. Okay. Now in this particular case, if another transaction has to withdraw an amount of 5,000 rupees, then in parallel to this particular transaction which is going on, okay, now in that particular case, the effect, first of all, this transaction and its success or failure should not be known to the other transaction. Okay. Now, how will it happen? Well, it will happen because the other transaction may not be allowed to proceed at all. Okay. Isolation involves that suppose this particular transaction has started and it has it has read this particular value and it has reduced the amount of X to 5,000, it has started. Okay, then probably at that point of time, the other transaction of withdrawal of 5,000 rupees may not be allowed to execute. Okay, it may be asked to wait till this particular transaction is completed. Right? So the effect of this particular transaction, okay, which ultimately is going to result in a balance of 5,000 rupees. All right. So that will be known, okay, that will be performed by this particular transaction. That is the responsibility of this particular transaction. The next transaction is not concerned with the failure or success of it. Right? So it will depend. Suppose this transaction fails. Okay. Then after its failure, the second transaction will, or the transaction of withdrawal of 5,000 rupees will be granted. Okay. Suppose it succeeds. Then it will start with the value of 5,000 and accordingly, whether it is going to be a success or failure, it will be on the basis of that particular state. So it only depends on the current or the state of the database at that point of time when the transaction is going to take over. The idea is that overall, all the transaction should leave database in a consistent state. And that is one of the most important things. So isolation is that this particular transaction has nothing to do with the other transaction. Okay, so it will not cause failure to another transaction because of its own, right? Although in one sense they may cause failure to other transaction in the sense, suppose the first transaction, this particular transaction is of withdrawal of, suppose here we are withdrawing 5,000 and next transaction is withdrawal of 6,000. So if the amount was 10,000, then 6,000, if that transaction starts first, okay, then this transaction cannot be executed. And if this transaction starts first, then that transaction cannot be executed. Right? That is all right. That does not violate the isolation property. What isolation simply says that we have nothing to do with each other. You are being performed independently and I am being performed independently. Right? The failure may occur because of whatever the state of data, not because of the transaction, the processing of the transaction. So this data value should not interfere. They should not interfere with each other in the sense that whatever one transaction is doing should not be visible to other transaction. Once it is complete, once that particular transaction completes, then the next transaction will take over, whether whatever balance is, it has to work on that particular balance. Okay, so that is the whole idea of isolation. So this is how the isolation property, which is one of the most fundamental property as far as database is concerned, works. But are there any more property? Yes, obviously there was a property called durability. Well, this is a very important property too. The property necessitates that once a transaction has been committed, the changes made by it be never lost because of subsequent failure. Thus, a transaction is also a basic unit of recovery. Now, that's a very interesting statement to make. Okay, now this is, if we can see what is durability in this particular case. The durability is that suppose the situation that the transaction has committed. So, this transaction has committed. All right. And once it has committed, the values are still not being written back to the secondary storage. The secondary storage assumed still contains 20,000. But there is a failure. So in that particular case, isn't this 5,000 and 20,000 an inconsistent state? But this durability property must ensure that after the failure, when the database restarts, it checks whether this particular transaction has committed or not. That means the database needs to keep track of every transaction with the help of something called log file. All right. So database is going to keep track. Okay, this transaction has not yet committed. Okay, roll back. Bring the transaction back. Suppose 5,000 was written into the database, it will be brought to 10,000 once again, right? But if the transaction has committed, then the state of the transaction should be brought to 5,000 and 25,000. So this is in a sense the property of what we call the durability property. So what we basically are discussing in this particular session, or what we are talking about, is basically the essence of transactions, which basically defines the importance of running multiple transactions in a particular database system. And all these transactions are going on together, all right, running together. And you might have noticed that when the multiple transactions are going on, it's all right. You are not concerned with somebody else's transaction. Why? Because your account is your account. You are dealing with your account. Suppose you are withdrawing money and thousands of people will be withdrawing money at the same time, and everybody's account is different, so there is no clash. Right? So parallel transactions can take place without any problem. But it is the isolation property, right? That if two transactions are trying to access the same data value, right? Then how to ensure that these two transactions are dealt with in that particular situation, right? It may be that one will be dealt first and then the next will be dealt at some point of time. So these were the concurrency related problems which we have discussed in the last session, which you can go through. So the other things which we have discussed in this particular session include the basic four properties of the transactions, which are atomicity, consistency, isolation, and durability. So please go through the material and just translate this particular learning and read from your material, and you will be benefited. With this, we end this particular session. Bye for now.